Hi class, tonight we're going to look into section 2-4 and it's on functions. If you want to go and open your textbook to section 2-4, that would be great. So what have we learned so far in chapter 2? Well, in section 2-1 we talked about ordered pairs and how they form these points or these coordinates on our graph. So if we have an x-axis and a y-axis, an ordered pair is just a pair of numbers, x and y. X comes first, y comes second. If you always forget, it's just alphabetical order. And we practiced plotting points on our coordinate plane. In section 2-2, we talked about graphing on the coordinate plane. So what we did here is not only did we graph ordered pairs, we graphed multiple ordered pairs, and we created, most of the shapes we created lines through them. So we sort of connected the dots and noticed relations in the coordinate plane. In section 2-3, we talked about how to interpret graphs. So say we were given a word problem and the graph increased and then stayed constant and then decreased again. We talked about what that might mean in the context of the word problem. So if this is like, time and seconds, and this is feet someone has traveled, we talked about what that might mean when the graph increases, stays the same, and then decreases again. So now we're in 2-4, functions. So what is a function? A function is a relation, so we know that word from earlier, a relation in which for every x, there is only one y, and that's a little different here. For every x, there's only one y, not 2 or 3 or 4, just one. So I'm going to draw a little graphical representation of this first. So I've got my x-axis and my y-axis, and I'm just going to draw a straight line, and this one's just going to have a positive slope. It's kind of straight. I'm not perfect, right? So if I have an equation here if I have the straight line, if I pick an x value, let's say I pick the x value of, let's say that's 3. I notice if I go up to my equation, it only has one y value. It only hits my graph here. And let's say that's 4. So for every one x, for every 3, there's only one y value, and this one has to be 4. I don't have to choose between two y values. There aren't 2 points that coordinate with the x value of 3. This is kind of how we say it must pass the vertical line test, which means if I take a vertical line, any vertical line, anywhere on my graph, it has to only cross my graph one time. If it only crosses your graph once, then we say it is a function. There's going to be a case where some equations or relations are not functions. So as long as it only crosses it once, right, for every one y, we're going to have a function. So that's the graphical representation. If we look at the numerical representation, usually in the form of a table, let me just pick a few coordinates for x, and I'll pick some random coordinates for y. Let's say it's 6, 4, 4 again, and then let's say it goes down to 2. If I look just in my x column, I notice that for every x, there's only one y value. 0 only goes to 6. 1 only goes to 4. 2 only goes to 4. 3 only goes to 2. There's only one y for each of these x's. The kind of nice, easy way to notice whether or not something's a function is if you look in the column of x's, there are no repeated values. So there's only one x, or there's only one y for every one x. Notice I don't have any repeats, 0, 1, 2, or 3. I do have repeats in my y column. I have 2 4s here, but it doesn't really matter. If I graph these 2 points, so the point 1, 4 and the point 2, 4, these I don't have to worry about passing my vertical line test. If I drew a vertical line through both of those points, it would only cross them once. So no big deal there. Let's look at some non-functions. So graphically, non-function. If I draw a relation or an equation, a graph, looks like this. Notice my vertical line test doesn't cross my equation once, my relation once, it crosses it twice. So no good, not a function. That means if this x value is 2 and this y value is 4 and this y value is -3, it means for this one x value of 2, I have 2 y values. I have a y value of 4 and a y value of -3, which means I have two y values, not just one. If we were to look at what this would look like in a table, then I have the 0.24 and I have the 0.2, -3. So 2 maps to 4 and 2 maps to -3. If you remember our mappings from earlier, if I have my x and my y, 2 goes to 4 and -3. Again, if you look in your x column, you've got repeated values. So again, if an equation in relation is not a function, if when you draw a vertical line it crosses it twice or 3 or 4 times. If when you look in your table you have repeated x values that go to different y values, so that's like, again, plotting these points, they'd be on top of each other, so it doesn't pass the vertical line test. Or if you're looking at a mapping, you've got two arrows kind of coming out of your input section, your x section. Good, okay. So a linear equation is a function. All lines are straight lines, which kind of makes sense because if I draw a vertical line anywhere, I'm not going to cross, or it's not, my equation is not going to cross my vertical line more than once. So again, this is a little bit of review from the sections before. If we needed to plot these points, we'll see that they form a line, a linear equation. So again, if I plug in -1, oops, no, I need to write -2 first, don't I? The first one they kind of did for us. -2 times -2 plus 2, you should get 6. +4 plus 2, 6. Let's plug in -1 from our x's. So again, all I'm doing is plugging it in here. So -2 times -1 plus 2. That'll give me +2 plus 2, which is 4. If I plug in 0, anything times 0 is 0 plus 2, I get 2. You should start noticing a pattern. So I'm guessing the next one might be 0. And -2 times 1 plus 2, -2 plus 2, yep, get 0, and so let's assume that's -2, but let's check. -2 times 2 is -4, plus 2 you get -2. Plotting these points, so -2, 6, -1, 4, my line was kind of already drawn for me, 0, 2, 1, 0, and then 2, -2. So notice it passes my vertical line test. Now also, if I look in my x column, I have no repeated values. They only go to one y value. -2, 6, -1, 4, 0, 2, 1, 0, 2, -2. So this is an example of a function. Now just because this is a straight line and the example here before is also a straight line, you might have functions that are curved. So again, you might have kind of a funky parabola. So if I draw my vertical line test, it only crosses my function once, anywhere. If I move this line anywhere, right, only crosses it once. You might also have a shape that looks something, I'm just going to graph it on the same graph. It looks like that. Again, if I grab my vertical line, only passes it once. It's when, I'm just going to squeeze one in here, do we have really weird looking things where it will cross my vertical line once here, which is fine, but once we get here it starts crossing it 3 times. So this little purple guy down here, not a function. These ones up here, yeah, these are functions. Okay, the last little concept we're going to talk about is function notation. So I have two things up here. I have an equation y equals 3x minus 1. And then I have this f with parentheses x equals 3x minus 1. So these things, I'm going to go ahead and tell you, these things are the same. The only things that are different is this y and this f parentheses x. The way we say this out loud, we don't normally say f parentheses x. We read that as f of x, a function of x, meaning x is my variable in my equation here. And I'm just going to say this is a function of x because when we're back to linear, to lines, linear equations are functions. So f of x. So the other thing is like y is kind of like the old way of calling an equation, y equals 3x minus 1, where this is the kind of new way to name linear equations. F of x equals 3x minus 1. Nothing has really changed. These two things still form the exact same line. Not worried about that. The only thing that is different is this notation that's used. So if I gave you a table before, just like we did on the previous example, and told you to plug in these three numbers, you would know what to do. You plug 0 in for x, and you get negative 1, so y would be negative 1. If you plugged in 1, you get 3 minus 1, 2, so y would be 2. If you plugged in 2, 3 times 2 is 6, minus 1 you get 5, so y is 5. The same thing is going to happen here, except I'm not going to write y, I'm going to write f of x. So if I still want you to plug these numbers in, it means plug in 0, so 3 times 0 minus 1, you get negative 1. Same thing, if I plugged in 1, I'd get 2. If I plugged in 2, I'd get 5. So again, nothing is changing here, just the way that we're writing it. And the way I've kind of explained it before to my students is that if I gave you this equation here, I would have to say, find y when x is 2. And you would know how to do that, right? You'd plug in x equals 2, plug in 2 for x, and you'd get 11 for y. Well, if I gave, and same thing in function notation, instead of saying this little phrase here, find y when x equals 2, I could just write this. F of 2, meaning what I want you to do is plug in 2 for x. So you plug in 2 for x, and you'd get 11. So if I were talking to, you know how math is called the universal language. If I was talking to a student in China, and I gave them that equation, I said this out loud, they might not understand me. But if all I wrote was this, if all I wrote was f of 3, they would know what this means. They would know what to do with that, because this is like the symbolic way for writing this type of sentence. Find y when x is 3. So that's it. Don't be confused with the f. Don't be confused with the parentheses. Don't be confused with the x. We'll talk a little bit more about functions in class. So if you have any other questions, make sure you write them down and you bring them to class tomorrow. Hope you have a wonderful evening.